Okay. Today we are going to see the details about chi-square distribution, how we uh, we all know the normal distribution as 1 by sigma root 2 pi e to the power minus x square by 2 sigma square. This is the normal distribution. Now, we take n random variables which are identically and independently distributed. Random variables. IID, sometimes we say that they are IIDs, identical and independently distributed random variables, each having this normal distribution. That is the basic premises of obtaining chi-square distribution, which is defined as the summation of the square of all these random variables. Okay. So, we first have the premises that there are n identically and independent random variables having this normal distribution. They are all having normal distribution, and we intend to show or find the distribution of their sum of their squares. This is obviously x 1 square plus x 2 square plus x 3 square dot 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 x n square. So, obviously, we first want to reach to the density function corresponding to this substitution y equal to x square. This is the density function for normal distribution, and we want to reach to the distribution of x square. So, we want to substitute y in place of x square. Now, just see what happens in terms of the condition of distribution function of probability. Let us write f y, which is defined as p y less than or equal to y. Sorry, this is strictly less than. So, this gives us probability of x square less than y, and we can easily write this as probability of capital X lying in between plus root y and minus root y. This is quite reasonable from the concept of inequality of numbers. If x square is less than y, we should say that capital X lies in between plus root y and minus root y. This is quite obvious. And from this, using the concept of distribution function, we may write that this is nothing but f of root y minus f of minus root y. This is also clear from the inequality rule, because x greater than minus root y is nothing but 1 minus x less than minus root y, and we have replaced that with f of minus root y. Now, to reach to the corresponding density function, we are to differentiate this with respect to y, and what we get? we obviously get f prime root y plus f prime minus root y by 2 root y. This is also obvious because root y, when you take the derivative with respect to y, gives half y to the power half minus 1, that is half y to the power minus half. This is the derivative of this into f prime root y, and this minus sign makes this plus. So, we can easily write that due to the transformation of y equal to x square, the density function of f x transfer to this. And obviously, here y must be greater than 0. And since f x is this, all the capital X follows normal distribution, this is density function this. So, we may write this equal to y to the power minus half by sigma root 2 pi and e to the power minus y by 2 sigma square, where obviously this y is always positive. Why this is so? Because when you put root y in place of x square as well as minus root y in place of x square, in both the cases we get the same term e to the power minus y by 2 sigma square, and here we have 1 by 2 root y. These two cancels out when you add them up, and we have only e to the power minus y by 2 sigma square, and this root y is written like this. Now, why I have written it like this? Because we intend to compare this with gamma distribution, which is b to the power p by gamma to the power gamma of p, and then x to the power p minus 1 e to the power minus bx. We may, if we like, write here this also, as we know that x or y is the dummy variable. Actually, we may replace here with x also, but since we have taken this transformation and have written f y as this, we intend to write the gamma distribution in terms of y. Now, we compare these two, and comparing these two, we claim that we have nothing but b equal to half. We compare these two and we have b equal to half, sorry p equal to half, this p is equal to half, very sorry, and b equal to 1 by 2 sigma square. Just see that we have compared these two, and the coefficient of y gives b equal to 1 by 2 sigma square, and if we put p equal to half, we have y to the power minus half, and this term matches completely, because when p is half and b is 1 by 2 sigma square, this is 1 by 2 sigma square whole to the power half, which gives us this, because gamma half is root pi. You can easily check. We compare these two, we have b equal to half to sigma square and p equal to half. So, they matches, and then we see that b to the power p and by gamma p gives sigma root 2 pi. So, we have this, and using this coefficient we may write this as the distribution of chi-square. What is chi-square? Remember, chi-square is and also remember that they are, I now wipe them out. Chi-square is summation xk square and they are identical and independently distributed RVs. This is very important, identical independently distributed RVs. So, probability of x1 square plus x2 square plus dot 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 xn square will be equal to this. This is termed as additivity theorem, and we have the distribution of chi-square as obviously 1 by 2 to the power n by 2. This is multiplied. Okay, we have root 2 and this root 2 is multiplied. We have sigma to the power n and we have gamma n by 2. Remember, we have root 2 pi here, and when root 2 pi is multiplied, sigma root 2 pi actually multiplied n times, we have nothing but this. And in case of e to the power, what we have? We have e to the power minus x n square by 2 sigma square, is not it so? This is e to the power x1 square into e to the power x2 square into e to the power x3 square dot 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 into e to the power xn square gives us e to the power minus summation xn square, and we replace u with this chi-square distribution, the variable, and then we have u to the power n by 2 minus 1, because remember that we have y to the power minus half there and it is multiplied. So, we have u to the power n by 2 minus 1, and this gives the chi-square distribution. I hope you can understand.